So, people sometimes have trouble the first time that they see a problem like this. All right? So, let's take a look through and see what we're up against. A sample of neon gas has a volume of 752 milliliters at 25 degrees Celsius. The volume is increased to 1.2 liters at a constant pressure. What must be the temperature in degrees Celsius? Okay, so let's go through and kind of highlight some stuff. So I have a volume of 752 milliliters, and then a second volume of 1.2 liters. So this is V1 and V2. And then go back to my highlighter, change my color. I have a temperature of 25 degrees Celsius initially, and a final temperature is what we're trying to find. Okay, so here's my T1, here's my T2, and that's what I'm trying to find. Okay, so again, convert this to Kelvin, pause it, make sure you get it right. That's 298.15 Kelvin. Okay, now I have V1 over T1 equals V2 over T2. This is another Charles's law. Now, I need to isolate T2. And a lot of people will tell me, well, why don't you just divide by 1 over V2 on both sides? If I do that, when I quote unquote isolate T2, it's on the bottom. Okay? It's in the denominator. When you isolate a variable, it always needs to be in the numerator. All right? So there are two ways that you can do this. Okay? You can cross multiply. So if I cross multiply, I get V1 T2 equals V2 T1. Cross multiply. Okay, then my next step is going to be to divide both sides by V1. So I get T2 equals V2 T1 over V1. All right, so that's one way. The other way is to multiply both sides by T2 over 1. Okay, so if I multiply both sides by T2 over 1, okay, and then I'm going to come over here for that. T2 crosses out on the side, and I get T2 V1 over T1 equals V2. Okay. Now I still need to isolate T2. So this time I'm going to multiply both sides by T1 over V1. Okay. So now, there go my T1s, there goes my V1. I'm left with T2 equals V2 T1 over V1, which is exactly what I got over here. Okay? So, now that I have that, I can just plug right in 1.2 liters times 298.15 Kelvin over V1, which is 752 milliliters. Okay? And then a lot of times people will just stop here and start calculating. Okay? But we're better than that. Because I see here that I have liters on top and milliliters on bottom. Well, I'm trying to end up with temperature, which means I need to end up with Kelvin. I need to get rid of these two units. Gotta pay attention to units. All right, so I'm just going to add my conversion factor onto the end here. There are 10 to the third milliliters in 1 liter. Okay, so now I do that. I get 4.8 times 10 to the second Kelvin. Well, the problem doesn't ask for temperature in Kelvin. It asks for temperature in degrees Celsius. So I have to subtract 273.15. And I get 2.0 times 10 to the second degrees Celsius. All right? Answer. Done. Okay? But there were a lot of places where people go wrong in this problem. The first thing is not isolating the variable correctly. And the second thing is to not convert units. Make sure that you're comfortable and careful with your units, or you're going to start getting problems wrong again. Good work.